All right, let's start off on number 1. So we're going to convert this to degrees. So for converting, it's either pi over 180 or 180 over pi to degrees. I just think of it like we're trying to get rid of the pi. So we do 180 over pi. And so we see we can cancel out those pi's there. And these will cancel out to 9. And so it's just going to give me 27 degrees if you do the 3 times 9. All right, next up here it says we got a 40% chance of snow on Tuesday, 50% on Wednesday. And what's the probability it will snow on Wednesday, but not Tuesday? So for Wednesday, first of all, that's a 0.5%, or it's not 0.5%, it's 50%, but that's 0.5. And then if we want both of these to happen, which we do, we'll do a multiplication. And then not on Tuesday, well, it says 40% chance it will snow on Tuesday, so that would mean 60% not snow. And then 0.5 times 0.6. We know 5 times 6 is 30, and then we would move the decimal 2 spots here to multiply the decimals, and we get 30. All right, next up here, we got some unit circles, so sine of 7 pi over 6. So how I do this, instead of drawing the whole unit circle, I kind of just visualize 7 pi over 6. So I know all the pi over 6's are kind of close here to the x-axis, and so this one's 7 pi over 6, just a little bit past pi. And the spot, the point there is negative rad 3 over 2, comma, negative 1/2. I know they're both negative since it's the third quadrant, so I can already cross off anything that's positive. And then I know it's kind of not, it's close to the x-axis, so it's further left than it is low, and so it's a small y value, so we know sine is the y value, and so it's negative 1/2. All right, next up, number 4 here, it says the circumference of a whole circle is 16 pi. Now, whenever they give me that info, I would set that equal to our 2 pi r and find the radius. So we divide both sides by 2 pi, and we get that r equals 8. And this is what's the area of a sector. And so we're going to switch over to the area formula, but not the whole circle, just the 120 degrees of a circle. So I'm going to go pi r squared, and then we're going to multiply by 120 over 360. Now I know that reduces to 1/3, so we're going to say 64 pi times 1/3. And so that obviously reduces to, or it doesn't reduce, so it's 64 pi over 3. All right, next up here, they tell us that y is 32. Get a different color here, okay, 32. And so they said, what's the value of x? And so I would use a sine here. So sine of 30 equals x over 32. And we know on the unit circle, I'll just kind of, once again, visualize that down here. So 30 degrees is right here. And we know that that is a small y value, big x value. So that's rad 3 over 2, comma 1/2. And so the y value is 1/2 equals x over 32. And we'll just cross multiply there. And so 2x equals 32. And so x equals 16 if you divide by 2. That does make sense because we would definitely want this leg to be smaller than the hypotenuse, like 64, and 32 would not make sense since it definitely has to be smaller than the hypotenuse. All right, next question here, secant of 120. So once again, we'll just visualize 120 here on that same unit circle. So 120 would be right there, just past 90. And the coordinates there are negative 1/2, comma, rad 3 over 2. We know the x is negative, the y is positive, and we know it's a big y value because it's pretty high up there. And so secant is a reciprocal. I would write down cosine of 120 first is negative 1/2. And so the secant is the reciprocal of that, negative 2. All right, next up here, we are going to write the equation for the function. So kind of the first thing I see here is I would try to identify the midline. It looks like the midline, if I can draw it correctly here, I'll try better this time. All right, it's right there at negative 2. And that also kind of shows me that we have up 3 and down 3 as our amplitude there. And so this is the shift is the midline, and then the up 3, down 3 amplitude. So I'm going to cross off this B here in the middle. So we know then that based on that information, we have an amplitude of 3 and a downshift of 2. And then it looks like none of these have a phase shift. So the next thing I would identify here is it looks like then we're starting at the midpoint. And this would be a sine graph. Since it starts at the midpoint, it goes up and down, and it would be a positive sine graph. So I'm going to cross off the cosine graph as well. And then last thing I guess I'd have to identify is the period. So the period here, where's a good way to identify the period? You know what? I think I would go from right here to right here. You can see there's a valley, then a hill. Usually we do a midpoint and then a hill and a valley, but we don't really have that here. So I do have the valley and the hill. And so this distance you can see from negative 3 pi to positive 3 pi would be 6 pi. And so that means that 6 pi would equal 2 pi over k. And so that means that 6 pi k equals 2 pi if you multiply that over. And so you divide by 6 pi. And you get k equals 1/3. So it looks like it's going to be A then and not D. All right, next up, number 8. So for this one, we got some socks here. And it says we're going to pull out 2 socks without returning the first sock. So what's probably the first sock and the second sock are both red. So we know we have a 2 out of, what's the total here? Looks like 18 on the first shot. And then if we don't return it, then we have a 1 out of 17 on the second shot. Now we can reduce this first to 1 out of 9 times 1 over 17. And so 9 times 17, I mean, I assume that that's 153 based on these options. And it is. Okay, so A. All right, next up here, period and correct graph. So for tan, we know that period is pi over k, so we have a k value of 2. And so our period is going to be pi over 2. So we kind of already know we can cross off this one and this one. And then really we can cross off this one, or we can't cross off that period, but we can cross off this graph because that's not a tan graph, that's a sine graph. And so we already know the answer is D here, but you really can see the period here from here to here is, this is pi over 4 and this is 3 pi over 4. And so if you subtract those guys between the asymptotes, you get 2 pi over 4, which gives you that period of pi over 2. So that's always the period for tan or cotan, is kind of the space between the asymptotes. All right, next up here, we're writing the equation again. So for this one, first of all, none of these have a phase shift, so I'm going to identify this as starting at a high point, so it's going to be a positive cosine graph if there's no phase shift. So really, right off the bat, I can say that that's D. You can see the amplitude is 2 right there. The period here you can see, actually what would be even easier than that is high point to high point. From there to there is a period of pi. And if the period is pi, then k must equal 2. So that one's pretty simple. All right, next one here, it says 40-inch pendulum. So we can kind of imagine the pendulum like this, and it's swinging this way and that way. And you can kind of imagine if it went all the way around that the pendulum length would equal the radius. So I'm going to say the radius here is 40. And then it says what's the length of the arc. And so arc length is like circumference. So it's 2 pi r. But not the whole thing. It's going to be just 18 over 360. And so then what I would do next is I would cancel these out and give me 180, and then I can cancel those out and give me 1 over 10, and so I get 40 pi over 10, which would be 4 pi. Next up, number 12. First thing I notice here is, once again, if we have no phase shift, then we're starting at a high point. That's going to be a positive cosine. So already can cross off A or B. And so the next thing we have to identify is the period. I would go low point to low point since we have a nice indicator there. And that looks like 4 pi from 2 pi, negative 2 pi to 2 pi. And so 4 pi equals 2 pi over k. And so 4 pi k equals 2 pi. and we just divide by 4 pi, and k equals 1/2. So it's got to be that one. All right, next up, band leads a 40-foot ladder against a building that is 30 feet tall. And how can the man calculate the angle of elevation? So angle of elevation is around there. So it looks like we would say sine of theta equals 30 over 40. So to get rid of the sine, we would say theta equals sine inverse of, you could say 30 over 40, or we could just reduce that to 3 over 4. So it looks like that's what they did. All right, next up we got period and phase shift here of a cosine graph. So period we know is 2 pi over k, and we do have a k value here of 2. It's multiplying by the x, so that's pi. And so I can cross off those. And then the phase shift, I do, in this case, I have to set the inside equal to 0 and solve that. So 2x equals pi, and x equals pi over 2. And so it's got to be D. All right, next up here, we are going to do a secant graph. And so first of all, in this one, I can cross off A because I know that's not a secant graph. That's like a sine graph. And so next up, secant has a period of 2 pi over k, and our k value is 1. So the period should be 2 pi because k equals 1. All right, so I can already cross off C now, and that's a tan graph anyway, so that wouldn't really apply. Now, we know that secant is based on cosine, and cosine starts at a high point. And so because cosine starts at a high point, then secant starts at a kind of an upward parabola that should be looking like that. Now we do have a phase shift here to the right, pi over 4, because of what's going on inside there. And so if I go to the right pi over 4, I should have I should have one of kind of these guys right there at a positive pi over 4. And so I see that that's going on right here at that positive pi over 4. You see that this one is really flipped right there. It's upside down. So if that was like the same function but negative, that's what that one would look like. All right, next up, number 16. So for this one, it says that the cosine is less than 0, and it says that sine is less than 0. And so if sine is less than 0, it can't be, actually it can't be either one of these. And if cosine is less than 0, it can't be either one, that one. And so it must be the third quadrant. So they say the sine is negative rad 13 over 7. So we would Pythagorean for the last side. So 49 equals 13 plus x squared. So that would be what? Minus the 13, 36 equals x squared. And so this would be x equals plus or minus 6. Now it is negative 6 since it's going to the left. So the cosine would be, wait, what are they asking for? Oh no, cotangent. So cotangent would be, let's see, first of all, it would be positive since we're in the third quadrant, so I'm going to cross off C and D. And tangent would be rad 13 over 6. So cotangent would be 6 over rad 13, which if you rationalize the denominator would be 6 rad 13 over 13. All right, next up here on this one, I automatically see this up 1 shift here. And so the only one that really has the up 1 shift is option D. So I already know that that's the answer because we need that up 1 shift. This does have a period of pi, and so that's why we have a 2x there. And it is a sine graph since it's starting at that midpoint, but that up 1 shift really determined this. All right, next up here, cosine of pi over 2. So that on the unit circle is up here. We know that spot is 0, 1, so the cosine, of course, is x. So it's going to be 0. All right, next up here, explicit formula, when we have 2 points, and so I think of these as points. And so I'm going to find the slope here. So y2 minus y1 over x2 minus x1. And let's see, 116 minus 26. 90, so that's negative 90 over 30. That's negative 3. And so I already know it's either A or D. And so to find the kind of zeroth term here, what I would do is just think of it like mx plus b. So y equals negative 3x plus b, and I'll just plug in one of these points. So negative 26 equals negative 3 times 10 plus b. So I'm going to add the 30 over, and so b must equal 4. And so it's got to be A. All right, next up here, we got another graph. So I see the midline here looks like it's at plus 2. So we need that up 2 shift, so I can cross off A already. And then, what else is it? It's got to be a sine graph since it's starting at that midpoint. So I'll cross off the cosine graph. And then the period here, it looks like it starts at 0 and ends at pi over 2. So if the period is pi over 2, I can set that equal to 2 pi over k. And then we know that 4 pi equals pi k, so then k must equal 4. So it's looking like option D then. All right, next up here, we're wanting to find the area. So area of a triangle, if it's a non-right triangle, we can always use 1/2 AB sine of C. And as long as that sine is in between the two sides, I can use it. So it looks like I got a side angle side right there. So that's going to be my info. So I got 1/2 times 6 times 10 times sine of 30. So I know that this will be 3 times 10 is 30 there. And then sine of 30, we're going to go to the unit circle. And that's rad 3 over 2 comma 1/2. And so I know that that's 1/2. And so this comes out to 15. All right, next up here, number 22. So for this one, it says, what can we use to find the sine x? So from 37, this is the opposite over hypotenuse. So I'm going to say sine of 37 equals x over 22. So 22 sine 37 equals x. However, that's not there. And so what I would need to do, so I would say that all the ones with 37 are wrong. But I see 37's has 53. And so what if I kind of called this one 53 and took it from there? Well, then it would be cosine of 53 equals x over 22. And so 22 times cosine of 53 would also work. And so that's option C. All right. Last up here, number 23. So for this one, I've got a sequence. It looks like it's multiplying by 5 every time. And so I know that's an exponential sequence. It's not linear. So I'm going to cross those guys off. And to multiply by 5 is going to look like that. You can also test those out. Just plug in 1 and 2 and 3 and make sure you get the right numbers. All right, now we got some select all that apply here. So for these ones, let's go through them. So the first one here, it looks like, let's see, if I have no phase shift, I would call this a negative sign. And it's got an up 1 shift. So a negative sign with an up 1 shift, I'm going to say it's not B, but it is D. Now, to be a cosine, let's see what we can do here. So both of these are shifting at left pi over 2, so they're saying to start right. Actually, I'll do this in a different color. They're saying to start right here. And if I'm starting back negative pi over 2, that would be a positive cosine. So I'm going to cross A off and select C. All right, for coterminal angles, we're going to add or subtract 2 pi, but in this case, it's going to be 12 pi over 6. And so if I add it, I'm going to get 17 pi over 6. And so that one's good. That one's not. If I keep adding here, another 12 pi, I get 29 pi over 6. And I got to guess keep going here. If I add another one, I get 41 pi over 6. So this one is good as well. That one doesn't even have a pi, so that one's no good. But what if I subtracted it? Well, I would get negative 7 pi over 6 on my first try. So there you go for F. And if I subtract it again, I would get negative 19 pi over 6. And if I did it again, I'll get negative 31 pi over 6, so not D. All right, next up, number 26. So for this one, I see we have a down 2 shift, which all of these equations actually have. Now, if there's no phase shift, I'm going to say that's a positive cosine. And so I'm going to cross off D and circle C. The amplitude does look like it's 4, though. So then if it's a phase shift and this one's to the left, pi over 2, it's saying it's starting right here. And then so I would say that's a positive sign. And so that's not A, that is B. All right, next one, which of these has a period of pi over 2? So what we need to know on this one is for tan and cotan, it's actually pi over k. So for A, it's going to be pi over 2, since k is 2. And so that one's good. For B, since it's cosine, it's 2 pi over 4, which is pi over 2, since k is 4. And that's going to be good as well. So remember the rules are different for tan and cotan. For C, it's going to be 2 pi over 1/2, which is actually 4 pi. So that is no good. For D, it's going to be pi over 4, which is no good since that's tan. And for E, it's going to be 2 pi over 4, which is pi over 2, so that's good. And then for F, it's going to be 2 pi over 3. So that's no good. So just remember on those ones, for tan and cotan, it's pi over k. Everything else is 2 pi over k. All right, next up, number 28. So for this one, the area of an equilateral triangle with side length 8. So I know these are all 8, and then we know that this is 60 all the way around for an equilateral triangle. So then we're going to do area equals 1/2 AB sine C. It doesn't really matter here because all of these are the same, so we know it's just got to be any angle in between the two sides, so it doesn't really matter which one you call here. And so this is going to be, what is that, 4 times 8 is 32, and then sine of 60, if you think about the unit circles up here, that would be 1/2 comma rad 3 over 2. So of course sine is the y value, and so that's going to be 16 rad 3. All right, next up here, number 29 asks us to write a cosine equation. Now, I'm actually going to use a negative cosine equation for that one. And then it looks like here the period goes from 0 to 2, so the period equals 2. So we're going to set that equal to 2 pi over k. And we're going to say 2k equals 2 pi, which would mean that k actually equals pi. We have an amplitude here of 4. No up-down shift though, so I'm going to say y equals negative 4, since we're starting at that low point, cosine of pi x. All right, next up here, they want me to write a sine function, and so if it's a sine function, I have to actually say it starts right there, since it is it starts at the midpoint. And so right off the bat, I can see we have a phase shift of pi over 4. It's halfway to pi over 2. We have an amplitude of 3, no up-down shift. And then what's the period here? That's a tough one. Oh, it's just going right there to 2 pi. So that's not too bad. It's a quarter past 2 pi, but it started a quarter past 0, so the period is just 2 pi, which would mean that k is 1. So I'm just going to say y equals 3 sine of parentheses x minus pi over 4 to do that phase shift. All right, next up here, they tell me the cotangent is 3 rad 11 over 1, and sine is greater than 0. And so if cotangent is positive, it couldn't be these two, but if sine is positive, it can be that one. So I'm going to go into the first quadrant, and so cotangent, let's see, that's going to be adjacent is 3 rad 11, and opposite is 1, so I need to find the hypotenuse here. So 3 rad 11 squared plus 1 squared equals c squared. So on this one, nope, I did it wrong. That's how most people do it, but you have to do 9 times 11 plus 1 equals c squared, since you have to square the 3 and the rad 11. So 99 plus 1 equals c squared, so 100 equals c squared, c equals 10. So that would mean that the cosine here would be 3 rad 11 over 10. All right, next up here, we got a cosine equation, which is nice. It starts at that high point. The period here is 8 pi. And so I'll let you guys do that one. We've done a lot of graphs already, so I'll just give you a hint. The period there is 8 pi. You can see high point to high point. Okay, next up we have a non-right triangle, and it says angle A, which is kind of arbitrary. Which one you call that is 60 degrees. Side B, so its opposite angle B is 10, and angle C is 75 degrees. And so then we want us to find, what do we want us to find? Side A. So this is what we're trying to find. Okay, so let's find this other angle here. So 180 minus 60 minus 75. So minus 60 would be 120. 120 minus 75, what is that? It's 45, okay. So since this is a non-right triangle, we use a law of sine. So sine 45 over 10 equals sine 60 over x. And so we'll cross multiply here. So x times sine of 45 equals 10 sine 60. Now we're going to have to go to the unit circle. So sine of 45, well, of course, that's rad 2 over 2. So x times rad 2 over 2. And sine of 60, which is 1/2 comma rad 3 over 2. Of course, that must be 10 times rad 3 over 2. Okay, so let's simplify this. I'm going to call this 5 rad 3 equals x times rad 2 over 2. And then we'll multiply by 2 over rad 2, the reciprocal there. And so I get x equals 10 rad 3 over rad 2. And if it was free response, you could leave it like that. If you wanted to rationalize it, you would multiply rad 2 over rad 2, which would be 10 rad 6 over a regular 2, which would just be 5 rad 6. But once again, I would accept that one as well. All right, next up, probability here. Randomly selected student prefers morning classes given that they are junior. So given that they are junior means we only go out of the juniors. So our bottom is going to be 16 plus 3 plus 18. And then the numerator is going to be the morning classes, so that's the 16. All right, next up is a sophomore or prefers evening classes. Now, we have to add up all of our sophomores. And this is going to be out of the total, whatever the whole total is. And so I'm going to say here is 11 plus 20 plus 17. And then we're going to add that to the evening classes. So it's 17 plus 17 plus 18 plus 20. But you can see here that we had some overlap, and so I need to subtract that out. That's the 17 that you can see we counted twice, like right here. So we got to subtract that out. All right, next up here, we want to write a sine equation. That's only natural since we're starting at that midpoint. And we see that the period here is 1. So 1 equals 2 pi over k. And so I can already tell that k must equal 2 pi because that would cancel out and give you 1. We have an up 1 shift here, so you have to take that in consideration. And I would say our amp is 1 since it's going up to 1, up to 2 and down to 0. All right, next up, 36. So for this one, without a calculator, well, we can do like, actually, the ones I already know are B. So for B, I know that that one's equal because when cosine and sine are complementary angles, they're always equal. And so for the other ones, then, I would actually think about the unit circle. So for C at pi over 3, I know that it's, what is that? 1/2 comma rad 3 over 2. So then I know that the sine is greater since it's kind of higher up there. And 2 pi over 3 is over here, so it's negative 1/2 comma rad 3 over 2. And so this last one I would say are equal because the signs are the same on either side there of the unit circle. And at 20 degrees, it's down here. I don't know what that is, but I can definitely see that the x value will be bigger because it's just further right than it is up. All right, next up, number 37. So for this one, we actually have a k value here of 1/3, and so the period is pi over 1/3, which is actually 3 pi. And so we should be finding kind of distance between the asymptotes at 3 pi here. So for option D, it's going from negative pi to pi, so that's 2 pi, so I would say that's not it. And again, here is negative pi over 4 to 3 pi over 4. That's a period of pi. Option B, from negative 3 pi over 2 to positive 3 pi over 2, that actually is a distance of 3 pi. So it's option B. These ones are way too skinny on number 37. All right, number 38, area of a sector, a central angle of 4 radians is 32. Find the radius. So we know area is pi r squared times whatever angle we are, and if we're in radians, it's out of 2 pi. So I know that the whole area is 32 here. I don't know what r is. I know we have 4 radians out of 2 pi. It does not say 4 pi, so I'm not going to assume that. I can cancel out these pi's and reduce this to 2. I'm going to divide by 2. So r squared equals 16, so r equals 4. All right, number 39 I actually already asked, so you can look back up at that one that we did before. For number 40, 4 pi over 3 is down here. We know that the pi over 3, this is pi over 3, this is 2 pi over 3. 4 pi over 3 is down here. And the coordinates there are going to be negative 1/2, comma, negative rad 3 over 2. So the sine value is the y value, negative rad 3 over 2. All right, next up we got a cotan graph. So we know the period here is pi over k, which is 2. So on option A, we have from asymptote to asymptote here a period of pi, so that's no good. Option B must be it, because we got to go from 0 to pi over 2. Option A again has from 0 to pi, and this one should be starting off with an asymptote. Cotan always does, so that's not it. All right, next up here, got a tangent graph. The period here is going to be pi, since there's a k value of 1. But we have the phase shift to the right, pi over 4. Now, tangent should always start at its kind of midpoint here. So it looks to me like it's got to be option C. Let's see, we got 3 pi over 4 there, negative pi over 4 there, so that's a period of pi. It's got to be option C. B has a period of pi. That's looking good, but no phase shift. Actually, it does have a phase shift. Never mind. It's a phase shift of pi over 2 since the tangent starts at the midpoint. Yeah. This one also has a period of pi, but it looks like a phase shift of negative pi over 4, so that's why we're not choosing it. And for option D, it's the period's way off. All right, number 43, area of a sector is 18 pi. If the radius is 4, what's the central angle in radians? Okay, so use our area formula again, which is pi r squared times theta over 2 pi, since we're talking radians. We'll set this equal to 18 pi. And then we know we can cross off the pi's here. And we know the radius is 4. So let's call this 18 pi equals 4 squared is 16 times theta over 2. And so that's really 8 theta equals 18 pi. Divide by 8. And that's 9 pi over 4. All right, 44 we actually also already did. It's the same as number 38. So you can skip that one or do it again if you like. All right, next up here, they say cosecant is 5. That really means that sine is 1 over 5. and tangent is negative. So if tangent's negative, it can't be that one or that one. If sine is positive, it must be this one. So that's 1 over 5. So you use Pythagorean theorem to find the last side and then find your trig functions. All right, next one here, negative sine function. I see we have an up 3 shift. The period here, it looks like it starts right there and ends at pi, so the period is pi. And we have an amplitude of 1, so I'm going to let you guys write that one as well. All right, and then number 47 here, it's cosecant of 135, so 135 is right there. Negative rad 2 over 2, comma rad 2 over 2. And so the cosecant is a reciprocal of sine, so that's 2 over rad 2, which will probably be rationalized as 2 rad 2 over 2, which is just rad 2. Right. Lastly, write a sine equation that has an amplitude of 3 and a period of pi over 2. So for period is kind of the tricky part here. We say 2 pi over k equals the period. So k pi equals 4 pi. That would mean k equals 4. So y equals 3 sine of 4x.